For this video in section 8-6, this is the third video, we're going to apply the law of cosines to solving triangles. Remember, law of cosines are in the situations of SAS or SSS. Notice in this case we have the lengths of two sides and their included angle in a triangle, so that would be a side angle side situation. So if we match up the length opposite our angle, we're going to have x squared is equal to, now it doesn't matter which of these two we choose first, so I'm just going to go 6 8/10 squared plus 23 7/10 squared minus, and then just keep things in the same order. 2 times 16 8/10 times 23 7/10 times the cosine of 25 degrees. Notice the relationship. This length is the side length opposite that angle. These two side lengths are the ones that include that angle. Now, there really isn't a lot to do to solve for x here. Remember, I can't solve for x with my calculator until it's solved for x in my equation algebraically. So all I have to do is take the square root of both sides. Now, because x represents a length, we're only talking about the positive square root, so it's not plus or minus the square root. And everything that we have here, I'm just going to write under the square root symbol. So this is all part of the radicand. Notice how I'm not worried about multiplying anything out. It would all come out to be ugly decimals anyway. So once I have it to that point, now I'm ready to use my calculator. So if I have the calculator that shows me everything, and I'll zoom in on this so we can see it a little bit better. Okay, I'm going to have the square root. So in this calculator, that's above x squared. So second, x squared. So now we see the square root symbol in a left parenthesis. Now I'm just going to have 16 8/10 squared plus 23 7/10 squared minus 2 times 16 8/10 times 23 7/10 times the cosine of 25 degrees. Now that parenthesis is going to close off the 25 degrees, but then I need to close off the grouping for what's under the square root. So when I hit equals, the length of that side is about 11 1/10 centimeters. Excuse me, meters. Now, I want to show you the same work with the calculator that doesn't show all of our operations. So in this one, remember I have to do all the calculation part and then take the square root. So in this one, I'm going to do parentheses to put everything that was under the square root together. So we're going to have 16 8/10 squared. I have to find my x squared key on this one. And that would be right here. Plus 23 7/10 squared minus 2 times 16 8/10 times 23 and 7/10 times, remember to do the cosine of 25 degrees, I have to do the 25, then the cosine. Now I'm going to close off the parentheses. So that's everything that's under the square root. Now do the square root. So the square root on this calculator is actually its own button. Some of them it hits second and then x squared. This one it's own button. Up to the nearest tenth, we would again have 11 1/10 approximately. Now that was a problem that was the side angle side situation. But another situation that we may use the law of cosines to solve is one in which we have all three sides of our triangle and we're trying to locate or determine the measure of one angle. Now the algebra on this is a little bit trickier. So here we want to find the measure of angle R to the nearest degree. So if I'm trying to find angle R, I have to look at the length of the opposite side for R. And that's the one that's going to be all on its own squared in the law of cosines. So this one will have 26 4/10 squared is equal to, doesn't matter which of these two comes first, so I'm going to have 19 2/10 squared plus 9 9/10 squared minus 2 times, and then I just like to keep them in the same order. So 19 2/10 times 9 9/10 times the cosine of R. Remember, when we write it this way, we're understanding that this means the cosine of the measure of angle R. So notice here, a little bit trickier, we have to solve for angle R. So remember, the things that are farthest away from what we're trying to solve for, we take care of first. So these two things being added, kind of the farthest operation-wise away from that. So I'm going to subtract both of those from each side of the equal sign. So we're going to have 26 4/10 squared minus 19 2/10 squared minus 9 9/10 squared. Now I know some of you are thinking, well, let's just go ahead and square those and then we'll subtract. You know what, folks, you're actually going to have to write more if you'd find those. So what do we have left? We have negative 2 times 19 2/10 times 9 9/10 times the cosine of R. Notice that all three of these are multiplied times the cosine of R. So what I want to do is I want to divide both sides by that product. So on the left side of our equation, we're going to have 26 4/10 squared minus 19 2/10 squared minus 9 9/10 squared, all divided by negative 2 times 19 2/10 times 9 9/10. And that will equal the cosine of R. Remember, to undo cosine, we use the inverse cosine. So when I do inverse cosine on this side, I'm going to get the measure of angle R. Just like having that first, that's our variable. On the other side of the equation, then, we're going to have the inverse cosine of all of this fraction. So it's 26 4/10 squared minus 19 2/10 squared minus 9 9/10 squared. And that's all divided by negative 2 times 19 and 2 tenths times 9 and 9 tenths. Now, notice by keeping these in the same order, how they kind of line up there. It doesn't mean we get to reduce them, because these aren't being multiplied like those are, but at least it's kind of a satisfying feeling that, okay, I have everything lined up right. These two are those two up there, and so on. We have now solved the equation for our unknown. So it's time to use our calculator almost. I'm going to ask you to actually do one additional thing here, and that's to put some other parentheses in. And the reason for doing that is because if you don't, your calculator won't interpret this correctly. Your calculator will want to try to divide this last number by the negative 2 and then multiply the answer by this. And these two it'll just subtract. So the extra parentheses are going to go around the numerator here and the denominator. Remember, these parentheses just mean multiplication. We'll use the multiplication symbol on our calculator. So we'll look at both calculators here. I'm going to move that up so we can keep it in sight. Here would be the calculator for which I'm going to see all of the operations. And need to get that kind of out of the glare. Let's see if I can move that. Okay, mostly out of the glare there. Yeah, if I just hold my hand up there, then it will work. So, this one I can do just as the way I see it. So I'm going to have inverse cosine. Now I have to put that left parenthesis for the numerator that you put in. So now I have another parenthesis. Now I'm going to do all of the numerator. 26 and 4 tenths squared minus 19 and 2 tenths squared minus 9 and 9 tenths squared, then close off the numerator. Divided by, now I'm going to have negative 2, don't forget the parentheses, negative 2 times 19 and 2 tenths times 9 and 9 tenths, close off the denominator, and now close off the entire group that are the big parentheses that we saw earlier. So now when I hit equals, I should get the measure of angle R. So notice in this case, the measure of angle R is about 127 3/10 degrees. Now, my directions did say to the nearest degree, since 2/10 is closer to 127 than to 128. Remember, that has to be 5 or above to round to the next largest. Our answer here would be that the measure of angle R is about 127 degrees. Now, I want to show that for the other kind of a calculator. So on this calculator, I'm going to have to do my grouping stuff first. So I'm going to have the left parenthesis, then another left parenthesis, 26 and 4 tenths squared minus 19 and 2 tenths squared minus 9 and 9 tenths squared. Now the right parenthesis for my numerator, divided by the left parenthesis, 2, make that a negative, times 19 and 2 tenths times 9 and 9/10, right parenthesis, and that's the denominator. Now I'm going to hit the right parenthesis again, and that's everything that's in the fraction that's inside the big parentheses. Now my calculator's ready for inverse cosine. So second cosine, and there's our angle of about 127 degrees. Now, as you're doing law of sines, law of cosines problems, probably a good idea to write those out. So remember, law of sines see how important it is that we understand the capital letter and the lowercase letter are different. So this is an angle measure. That's the length of the opposite side. Angle measure, opposite side length. Okay? And if I do the reciprocal, so the lengths are in the numerator and the sine of the angles are in the denominator, that's okay. Two numbers are equal, their reciprocals are equal. So there would be a law of sines. Now, for law of cosines, notice we could start with any of the side lengths. The important thing is understanding that this side length is opposite the angle in the formula. So if we have a squared equals, then we'd have b squared plus c squared minus 2bc. Those lengths and those lengths, they're the same, times the cosine of angle A. So it's a good idea to have those written out. So this, remember, is the angle side angle situation, or the angle angle side. This would be the side angle side situation, or the situation where we know all three sides. So if I know two sides in the included angle, two angles in the included side, or two angles in a non-included side, I'd use law of sines. If I have two sides in the included angle, or all three sides, that's a law of cosines. Remember, these are for oblique triangles, triangles that do not have a right angle. If they do have a right angle, boy, it'd be a lot easier to just use the regular sine, cosine, or tangent. So these are more complicated formulas when our triangles are not right triangles.